Relative frequency. A six-sided dice was thrown repeatedly. After every 100 throws, a cumulative number of sixes thrown were recorded. Complete the table below, which gives a summary of the results obtained. So 8 sixes in the first 100. 8 divided by 100 is 0.08. 28 sixes in after 200 throws, so 28 divided by 200 is 0.14. So to fill in the gap here, 60 divided by 300, okay, I can cross the zeros off and I'm saying to myself, 6 divided by 3 is 2, but then because I'm dividing by 30, it becomes 0.2. 72 divided by 400 is 0.18. 80 divided by 500, I cross the 0 off. 8 divided by 50 is the same as 16 over 100, so 0.16. Plot these in the relative frequency. I know after 100 throws, the relative frequency is 0.08. After 200 is 0.14. So my highest value is 0.2. So I've got 0.1, 0.2. So 0.08 is 0.01, 0.2, 0.3, so on. So across 100, up 0.08. Across 200, up 0.14, 0.10, 11, 12, 13, 14. Across 300, up 0.2. Across 400, up 0.18. Across 500, up 0.16. From the table, which value gives the best estimate for the probability of throwing a 6? You must give a reason for your choice. The one on the end always gives me the best value, so it's 0.16, and the reason being is the greatest number of throws will be the best estimate. Do I think this is a fair dice? I would say yes. I think it is a fair dice because my relative frequency was 0.16, and on a normal dice it's 1 out of 6, which is also 0.166, which is very close. November 2016, Unit 2. Right, this time they're telling me, they're giving me the relative frequency and I need to work out how many. So for after 3,000, they're saying how many of the first 3,000 sockets tested were defective. So out of 3,000, okay, the probability if I'm going up there is in the middle of 0.04 and 0.05, 6, sorry. So it's 0.05 times 3,000, okay. So 0.05 times 3 would be 0.15, times 30 would be 1.5, 15 and 150. So there's 150 of them were defective. Write down the best estimate of probability. The best estimate is always the very last one. So the very last one in here is 0.42468. So it's 0.048. And the reason being, okay, the most accurate probability is after the experiment has been completed the most times. So the most accurate probability is after the experiment has been completed the most times.